Hello, on this video I'm going to talk about binary tree in C++. If we do a search for binary tree, we're going to find a lot of those binary trees. And binary tree is a data structure that has a node, and each node has the most of two nodes as children. So people call it a parent node and then a child node. And then this will be child of this parent, and so on. Now there are many types of binary tree. The type that we're very interested is a sorted binary tree, and there will be something like this one right here, where the child to the right is bigger than the parent, and the child to the left is smaller than the parent. So 5 is bigger than 4, and 2 is smaller than 4, and so on. So we're interested in this type of tree right here. So each tree are made out of nodes, and each node has basically three things: data, whatever data you're looking for, whatever data you're interested, a integer, a words, or maybe whatever data it is, or maybe it has multiple data, or whatever it is. And then there's a pointer that points to the left child, and another pointer that points to the right child. So let's create now a program that has a binary tree. First step is to create a class node that will hold these three things. So in Visual Studio, I'm going to create a Win32 console application. As always, a empty project, and then I'm going to add a CPP file. I always like to name it main.
Main codes.
I always like to write a little high just to make sure my project is correctly set up. So now let's create the node class. Add a class, and I'm gonna name it node. And this node we have the three things: data, I'm putting as an integer, and then we're gonna have a pointer called left and another pointer called right. And right here on node, I'm going to go to definition, and what it does is a shortcut for me to go to the definition of that function. In this case, it's a constructor. I want to come here because my left node, I want it to be a null pointer, and I want my right to be also null pointer. And the reason is because every time this node class is instantialized, then left and right will be null pointers. So here's my node implementation. Here's my node header, and that's all for the node class. So I'm gonna close the node class, and now we coded one of these guys. Now let's create another class to put everything together. Right click, add class, and this class is going to call bin3 for binary tree. And the binary tree, I'm going to add my include stream. And also want to namespace standard. So now, from my binary tree class, I'm going to create a private, and then I'm going to create a pointer to the heads or to the roots. I'm going to put heads. Now I'm going to highlight the constructor, and then I'm going to press F12. And if you remember, F12 is go to definition, and that takes me to the definition, or in this case to the constructor. So I hate to be coming here and clicking and looking for that, so I use the shortcut, which is F12, and it takes me right there. So I love this. So the heads, I want it to be null pointer as well, and that tells me that whenever the tree is created, then it's empty, and then we can start including more more nodes in this tree. So my next step is to create a function to add nodes on this binary tree. So I'm going to the class view and right click on my binary tree, and I'm going to add a function. Returning type is void, the function name is add, and parameter is an integer, and that's a data. Add, everything is default. So this is the public add. I'm going to create another one, another function. Returning type is also void. The function name is add, the same name. Parameter type is integer. I'm going to put here node, and there is no parameter type node type here. So I'm going to put integer for now, and then later I'm going to fix it. And then data, add, and access, I'm going to put a private now, and finish. So I have here now two functions with the same name, but they have a different parameter. And whenever you call, it is not going to be confused, because it knows when you pass two parameters, it knows you're calling this function, and if you call the function add with one parameter, it's going to call this one here. And this is private, not public. So this is your private and this is your public. Now remember, I did not want int nodes, I wanted node. But there was no option to have a node. So I'm going to manually fix here. So going back to the binary tree header, I'm going to fix here also from int node to node. And also the wizard made a mess here. So I'm going to move the public together with the public, and the private together with the other privates, and these two keywords here I can just delete. I like to keep it well organized, so just one public sets of data and one private sets of information as well. So why did I create two functions with the same name? Because the user, the main, does not need to know any pointers whatsoever. Whenever the main calls the function, the main is going to call this one only, and all the main has to do is pass one integer, and that's it. And then the binary tree class will decide where the thing goes and how you're going to insert, how you're going to add that extra node. So the user is going to call this function here, and if it calls this function, the first thing we need to check is if the binary tree is empty. So if the head equals null pointer, then we know that this tree is empty. So if it's empty, we're going to create the object for the head, and then head data equals data, and then we are done. So this inserts on the head and done. Now if it's not, if this binary tree is not empty, then we need to go down to the next to the child, either to the left or to the right, to insert this data. Hence, here comes the other one we created, and we're going to call this function here, because this function is going to decide where it needs to insert. So add, and we're going to pass head, comma, data. Very simple. So this will be the recursive call, which is this one right here. So when we get here, we need to decide if the data is going to go to the left or to the right of that node. Because if you remember, we are interested on the tree that is sorted, the binary tree that's sorted. So if the data is smaller than the node's data, then we go left, else we go right. Now again, I'm not testing here one more time, because I'm assuming that all the data coming from the user or from the main will not be repeated. If the data is repeated, then you need to check it or do something else, or put a counter on the node. But we're assuming that there's no repeated data. So if the data is smaller, let's go to the left. And all I have to do now is check if the node left equals null pointer. Then very simple, if it's null pointer, then node left equals new node, so it's not null anymore, and then node left data equals data. Now this can be a little confusing right here, so let's go over line 36. So I have a node, and the node is pointing to nothing. So after pointing to nothing, right here on line 35, I created this node here, and then I need to set the data. So if the node going to the left, the data equals the data that we pass as parameter. Now what if that node is not null? Well, if not null, that means it always got something on it. So if all it has something on it, we just call this function recursively, And now instead of passing node, we pass node left, comma, the data that we're passing. So this is to the left, and we can do the same thing going to the right. I'm going to copy everything here and paste. Copying and pasting is very dangerous, but I'm gonna do it because we developers are very lazy, maybe efficient, I don't know. So here we're going to the right. So if the node right equals no pointer, then the node right gets the new node, and the node right data gets the data. Else we need to call and pass the right nodes and the data. So here is my entire add function. Again, reviewing this function, we have basically two options. If the data is smaller than whatever has the nodes, or if it's bigger, and if it's smaller, it tries to enter to create a node if the left is pointing to new pointer. If it's not, then call it recursively. And the same thing with the right. So now let's go to the main. And on the main, I'm going to include the binary tree. And now we can call a binary tree b3 and b3.add. I'm going to add a number 10. And then I'm going to add 20, then 15, and then 30. Those are going to go to the right, and then to the left I'm going to add number 5, the number 6, the number 4. And if I run this program, nothing happens because it's adding, but it's not printing. So in the next video, I'm going to show you how to traverse this binary tree.